Welcome to Spring LIB.
So here, because the translational acceleration is zero, we're going to have specifically translational equilibrium. So we can say that the sum of forces in the y direction is going to equal ft cosine of theta minus mg, and this will equal 0. So we can say that the force tension is going to be equal to mg over cosine of theta. At this point, we can say that the sum of forces in the x direction equals force minus force tension sine of theta, and this equals 0. So this means that the force is simply going to be equal to mg tangent of theta. At this point, for part A, we know that dr is going to be equal to L d theta. And so we can say that the work done by that force is equaling the integral from the integral of the dot product between the force and the change in the distance or the diameter or the radius. And we're integrating from 0 to the theta naught, or the original theta, of f cosine of theta L times d theta. Again, we can only use the x component, so that's why we have to multiply f by cosine of theta. And we find that the work done by the force will be equal to L times 0 to theta naught times mg tangent of theta cosine of theta d theta. And so the work done by the force will be equal to mgl times the integral from 0 to theta naught of sine of theta d theta, which is equaling mgl 1 minus cosine of theta naught. So essentially, this would be the work done, the formula for the work done by the force. For part B now, we need to recognize that the angle between the force of gravity and direction of motion is 90 plus theta. So we can say that the work done by gravity is going to be equal. It's going to be equal to the square to the integral of mg times dr. This will equal mgl times 0 to theta naught times cosine of 90 plus theta, again d theta. This cosine of 90 plus theta simply means that the work of gravity is going to be equal to negative mgl 0 to theta naught of sine of theta d theta. So work of gravity will simply be equal to mgl, and then here would be cosine of theta, not minus 1. So exactly the opposite. And that would be the formula for the work done by gravity. Now, it's something to note that the force tension is perpendicular to displacement. So if that's the case, that means that the work done by the tension force is going to equal 0 joules. And because the change in kinetic energy equals 0 joules, we can then say that the net work on the object is going to be 0 joules. And that is the end of the solution. Thank you for watching.